And now continuing on, part 2. As I was saying, before we can prove this, AC equals BC, we'll first need... Oh, I was saying that if we knew the two triangles were congruent, then AC... And these were corresponding parts here on the diagram. If these were corresponding sides, and these two triangles are congruent, then corresponding parts of congruent triangles are congruent. And so we would know that these are congruent to each other. And if they're congruent to each other, they have the same distance, and we're done. That's part of the definition of congruent, is that they have the same measurement. So we first need to prove that they want to first prove that the two triangles are congruent. So we want to prove that triangle AMC equals, there's congruent, sorry, to triangle Okay, we know that both triangles contain a right angle. We can just say that CMA and CMB are right angles. You might be wondering, where is point M? We never labeled it. It's in the directions to locate this point M. So they're saying that these are two right angles because this is a perpendicular bisector, so it is perpendicular, and this is a flat line, so it's 180. So if this is 90, this is 90. Also, just part of the definition of perpendicular bisector. In fact, that would be the justification for the statement, is definition of perpendicular bisector. But we also know that the big segment AB has been cut in half by the midpoint and the perpendicular bisector. So AM and BM, or MB, are congruent. They're the same length. Two congruent segments. So AM segment is congruent to MB segment. Oops, that's the wrong hat. I should have said BM. Regrets. Obviously, the segment from C to the midpoint of the segment of AB is a side of both triangles, so it's congruent to itself. That's the reflexive property. So C down to the midpoint is congruent to C down to the midpoint. That's in both triangles. Okay. So the triangles are congruent by SAS, triangle congruence criteria. So in fact, we do prove that AMC is congruent to BMC by SAS. And this is a side, this is a side, and this is the angle. Of course, the angle, just for pattern purposes, I wish we would have proven or shown that some segments matched, and then the angles matched, and then the segments matched. Do it in order. 1, 2, 3, SAS. That's the side statement, that's the angle statement, that's the side statement. Okay, since the triangles are congruent, the segments of AC and BC are congruent. Okay, A to C is congruent to B to C. So those are these things. These are the ones we wanted. We wanted to show that they were the same, that's equidistant. That if you're on a perpendicular bisector, then you are equidistant from both ends. No matter where you are, you'll be the same distance from both ends. That's what we wanted to prove. We've shown that. We use C, P, C, T, C. Since triangles are congruent, those segments are, because they're corresponding parts. Therefore, any point C on line L, the perpendicular bisector of segment AB, They're referring to L. If you're on line L, which is the perpendicular bisector of AB, and your any point C on that line, then U is equidistant from the endpoints A, B, A, and B. I think there really should be one more statement that says this, but oops. Maybe not. Maybe since I'm screwing it up, there shouldn't be. Yeah, well, whatever. All right, let's wrap this up real quick. Tia thinks Tahani is brilliant, but she would like the ideas to flow more easily from start to finish. Arrange Tahani's symbolic statements in a way that someone else could follow the argument and see the connections between ideas. Okay, let's do it. Actually, you know what? Let's do that tomorrow. That's long enough for one day because we have another activity we're doing as a class. So part 3 will be tomorrow.